questions until Dr. Brown is finished his presentations. You can put them in the chat if you wish, and then we will go through a Q&A at the end. But he's got a lot of detailed, comprehensive information to present to you this evening. So welcome to Women's Liberation Front, Dr. Brown. And I would love to turn over the floor to you and let you go ahead and present.
All right. Well, Sharon, thank you so much. And it's great to be here. And with the turn of events, I'm just so excited to have this happening and so appreciative of this opportunity. All right. I'm going to see if I can share my presentation here. And it looks like it's working.
Yep.
All right. And so just to introduce myself a little bit, my name is Greg Brown. I'm a professor of exercise science at the University of Nebraska at Kearny. My primary teaching responsibility is exercise physiology, which I teach at the undergraduate and graduate level. I also teach other classes like sports nutrition, research methods. I teach a class now in exercise for special populations, such as those with diabetes or heart disease or children or the elderly, things like that. And I've been here going on 21 years now at UNK. All right. I do want to say thank you to Robert Hayes from the Tewksbury Public Library, who reached out to me several months ago to make this presentation. I really think that Robert made a good faith effort to allow me to make this presentation. I want to thank Charles McCrisky from Democrats for an Informed Approach to Gender for really introducing me to Robert to get this together. And I'm really grateful that the Tewksbury Public Library has had a change of heart and has agreed to host this presentation tomorrow night. So I guess if you know somebody that can't watch it tonight, they could watch in person tomorrow. And I am disappointed that we live in a time when people threaten the librarians to try and influence public policy or to squash opinion or news or anything. And I want to say thank you to Sharon and WoLF for having the backbone, let's say, to step up and host this presentation with no fear. And so I greatly appreciate this opportunity. All right, and just a little bit about where Kearny, Nebraska is, because most people probably haven't heard of it. All right, so here we are, we're in south central Nebraska. That's the Platte River running by. If you've driven the 455.32 miles of Interstate 80 that runs through Nebraska, you've passed under the archway down there in the bottom corner. That's a museum that was put up just 2001 or so. So that's one thing you might notice about Kearny, Nebraska. The other is you see the town sign, Kearny, Sandhill Crane Capital of the World. I don't think that was voted on by the Cranes. I don't think anybody else voted on that. I think that the City Chamber of Commerce decided to adopt that title. But if you know someone that is into bird watching and they've come to see the Sandhill Cranes, there's a good chance they've come here because during the spring migration, during the month of March, we'll have several 100,000 up to 1 million Sandhill Cranes between Kearny and Grand Island. There's this 50-mile stretch of the Platte River that they love. And it's just an amazing sight. And as I say, this is not a paid advertisement. About the only other place you may have heard of Kearny, Nebraska, if you read Around the World in 180 days, or Around the World in 80 Days, there is a part in the book where their train is stopped at Fort Kearny and Passepartout gets kidnapped by the natives and they stay there for 3 days to get him back. So those are the things you may have heard of Kearny for. All right. And one of the things I want to point out in this presentation, I'm going to go over a little history, right? How did we get from this in 1990? Kindergarten Cop, right? I guess I was about 20 years old when that movie came out. And you've got the little kindergarten boy who says boys have a penis and girls have a vagina. And that was peak comedy and everybody laughed. And people were also a little taken back that that would be what a 5-year-old boy would be saying. And then we went from that in 1990 to here we are in 2024. And if you go to the website, she1.org, where they're documenting 717 female athletes that have been displaced from 1,055 opportunities to advance in sports because of males competing in the girls or women's category. And so I just think it's interesting to look at this over the course of 34 years, this change from really everybody knew what a man and a woman or a boy and a girl, male and female were. And of course, they had separate sports categories to a time now where there are questions about this and we need these presentations. And I saw Linda Blade on here, so I've got to give mad respect to Coach Blade for this idea for the timeline. I'm going to try and go a little short on this, but basically from 1968 through 1996, the Olympics did sex verification testing with a biologically based test looking either for sex chromosomes or the SRY gene to ensure that males were not competing in the female category. In 1996, Olympic athletes were surveyed. 82% of the female athletes said it was important to verify that only females were in female sports. 94% of the female athletes said they experienced no discomfort or anxiety by the sex verification testing. And yet in 1999, the International Olympic Committee ceased doing sex verification testing. Then in 2003, the International Olympic Committee adopted what they called the Stockholm Consensus, stating that if a male went through castration and genital reassignment surgery and lived for 2 years under medical care for their transsexualism, then they could compete in the female category. Right? And that was in 2003. 2011, the NC2A adopted their transgender policy where they stated that if a male suppressed testosterone for a year, no specific level or anything, just suppressed testosterone for a year, then he could compete in the female category. And then in 2015, the International Olympic Committee adopted a transgender policy stating that if a male suppressed his testosterone below 10 nanomoles per liter, then he could compete in the female category. Oh, and he had to live as a woman for a year. So suppress testosterone for a year, live as a woman for a year. I want to point out 2003, 2011, 2015, there wasn't research that showed reducing a man's testosterone concentrations erased male advantages, right? That would have been major, massive headline news, and it just wasn't there. And that's about when I started paying attention. I'm like, wait a minute, if there's this policy from IOC, I should have seen it. It would have been in the major journals or topics of discussion at sports medicine conferences or something. In 2016, in the women's 800-meter run at the Olympics, the gold, silver, and bronze medalists were all males with a disorder or difference of sex development. So we see 3 males taking place in the women's 800-meter run in the 2016 Olympics in Brazil. In 2019, CC Telfer won the women's 400-meter hurdles in the NC2A Division II. CC Telfer previously competed for 3 years as a male, as Craig Telfer, was ranked 200 or 300th, never qualified for the NC2A championship, but followed the NC2A policy, suppressed testosterone, identified as a woman, became a national champion. I had students that were at that, not competing against CC Telfer, but at that NC2A Division II championship. And they came back to class and asked me, said, what the heck's going on, Dr. Brown? Also in 2019, that's when we saw Selena Soul and her colleagues suing the Connecticut Interscholastic Athletic Conference because they had been deprived of opportunities to win championships by 2 males. This brings us up then to 2020. In 2020, Idaho passed the first Save Women's Sports law in the United States, stating that one must be female to compete in girls or women's sports. That's also when we saw Leah Thomas, who again followed the NC2A policy. Leah swam as Will and was ranked not an NC2A championship qualifier at all, ranked 45th to 100 something, depending on which event. Follows the NC2A policies, competes in the women's category, wins a national championship, and competes in several women's championship events. That's also when we saw Laurel Hubbard, who Laurel, again, was a male up until about 36 years old, then identified as a female, followed the Olympic policy. Laurel Hubbard, at age 43, qualified to compete in the Olympics in the women's weightlifting category. Now, that should tell you something. When you have a 43-year-old person competing in the Olympics in weightlifting, in a sport where 25 is typical age and 28 is old. That leads us up to 2021, 2022, when the NC2A, International Olympic Committee, really washed their hands of it and left it to the sport governing bodies to determine who is eligible to compete in the female category. Also, currently we have 25 states that limit participation in girls and women's sports to those who are female. 6 of those states currently have legal challenges. And so now there's a wide variety of policies. So you can see World Aquatics, World Athletics, UCI, which is World Cycling, World Rugby, state that if you have experienced male puberty, you cannot compete in the female category. There are other organizations, other governing bodies that say that if you identify as a woman, you can compete in the female category. So it's kind of a mishmash because the NC2A and IOC washed their hands of it. And then, of course, we had the whole controversy in the Olympics this year with women's boxing. Which brings us to this really important question. Sex and gender. Is there a difference? What is the difference if there's a difference? I think a lot of people my age or maybe even a little younger, definitely older, sex and gender have been used interchangeably for a really long time. But if we look at the American Psychological Association dictionary, it states that sex is really the biological traits that makes one male or female, and gender is more of how do you identify as masculine or feminine based on social expectations and such. So I think it helps to kind of have this differentiation where we can determine if something is sex affected or not. But keep in mind, this differentiation is not always observed. I think we've all filled out forms, whether it's for the government or a library card or even just a survey online. It asks for sex and maybe it means gender. I see this actually in scholarly articles I review, where I have to basically send it back to the authors and say, okay, are you measuring sex or are you measuring gender, to make sure that it's clear? So to start with this, right, looking at sex, sex is a biological factor. Human sexual reproduction is binary. You have the male sperm to unite with the female ova. We're all here because that happened. There's not a third option. There's not an in-between option. So in order to keep the human species going, we have to have male sperm and the small gamete unite with the female ova, the large gamete. At conception, we're given sex chromosomes. XX chromosomes for female, XY chromosomes for male, right? And so we could really say from a biological standpoint, sex determination begins at conception because we get the chromosomes. Chromosomes carry genes. Genes encode for proteins. And as a human being, we're just a big pile of proteins. And just our proteins come together in the right place, in the right shape, and the right time to do the right things. But we're a big pile of proteins. And again, as far as sex goes, that goes back to a conception if you have XX or XY chromosomes. At about 8 weeks of gestation, that's when sex differentiation occurs. That's when you start to see the development of either the female reproductive system or the male reproductive system. And then typically the development of the reproductive system, genitals, ovaries, or testes will follow either the male or female pattern based on, is your body designed to make sperm or is your body designed to make ova? Sex is incredibly important. Just a couple of quotes up here on the screen, but every cell in our body has a sex, right? For the Olympics, they would do a cheek swab, and you could use that cheek swab to see if someone has XX or XY chromosomes. We can get on various commercial genetic sites, do a cheek swab, put it in a test tube, send it in, and come back, and they will tell us if we're male and female, along with other information on our DNA. As I mentioned, chromosomes carry genes. Genes encode for proteins. One particular study looking at over 18,670 protein coding genes, over 6,500 of those genes had sex differential expression, meaning that males and females, the proteins are going to work differently because of sex. And I like this quote, the effects of the Y chromosome dwarfs all other DNA polymorphisms in the human genome. So in other words, if you have a Y chromosome, pretty much you're going to be male, and that's going to have more effects on your body than any other combinations of DNA that we really know about. Which brings up the idea of disorders of sex development, also sometimes called a difference of sex development. All right, this is a situation in which the reproductive system doesn't follow the typical pattern. Right? So this may come because a person is not given XX or XY chromosomes. They may just have an X chromosome, or may have two X's and a Y, or two Y's and an X. These are things like Turner syndrome and Klinefelter syndrome. But these individuals, their sex isn't ambiguous. At birth, it's clear if they are male or female, so they have a disorder of sex development, but they're still very clearly either male or female. Their body is still centered around production of either ova or sperm. Now, someone with a disorder of sex development, a DSD, it could be a variation in morphology, so the body doesn't shape quite right, such as hypospadias, which literally, I mean, that's just the opening of the urethra is not perfectly aligned in the tip of the penis, right? That's considered a disorder of sex development, but the person's not going to be ambiguous whatsoever if they're male or female. Could be congenital adrenal hyperplasia, where the adrenal glands are a little bit larger. Most people with congenital adrenal hyperplasia probably don't even know they have it until maybe later in life when they're starting to have some irregularities and some things. But again, sex wouldn't be ambiguous there, which then leads up to situations in which sex may be ambiguous. These are the conditions called intersex. This is what is thought happened with those two boxers in the Olympics. When they were born, their genitals were unclear, and so this is where the term sex assigned at birth would be accurate. They were assigned female, but they were really male. It's important to point out that intersex is an extremely rare 0.02% of all births are someone who is intersex. Intersex is not someone who's really in between male and female. That's where the term intersex is misleading. Their sex is ambiguous at birth. Here in the United States, by and large, it'd be pretty quickly identified through genetic or chromosome or something testing, all right? And again, all intersex conditions are disorders of sex development, but not all disorders of sex development are intersex, right? Intersex is really rare. So if we look at it, males are 49.19% of the population, females are 50.79%, and intersex is 0.02% of the population, which again, tiny percent of the population. Yes, across 8.5 billion human beings, there's a lot of intersex people, but it's a very small percentage of the population. And again, this is a biological condition. We know what causes it. We could do either chromosome or gene or hormone testing to identify it. It's also very important to notice that someone who is transgender is not intersex. And Claver has done research with this. We're looking at the sex chromosome karyotyping, gives no insight if someone is transgender or not, right? And we don't have a biological explanation for why someone would be transgender. You can't get a blood test or an MRI test or any kind of testing, biologically based testing, to identify if someone is transgender, but we can for intersex and disorders of sex development. I want to say here, someone who is transgender, someone who is intersex, someone with a disorder of sex development, they're still our fellow human beings. They still deserve kindness, love, respect, those types of things. But as I'm going to present, there are some places where sex really, really matters, and sports is one of them. So if we look at this, if we look in adults, there's biological differences between males and females. I think we all know this, right? You don't need someone with a PhD in exercise physiology to tell you this. Go back to kindergarten cop. I think any of us that had puppies or kittens or grew up on a farm or something like that know there's differences between males and females. Human beings, we're mammals. And so those mammalian differences are characteristic for us. There's differences in the amount of body fat between males and females and where the body fat is stored. There's female or gynoid pattern body fat storage. There's android or male pattern body fat storage. Males have larger muscle fibers. And when I say larger muscle fibers, I mean whether you measure bigger diameter or circumference or cross-sectional area, males have larger muscle fibers. The muscle fibers contain more of the contractile proteins. Having more contractile proteins, larger muscle fibers are stronger muscle fibers, right? Males also typically have more of the type 2 or fast twitch skeletal muscle fiber type. Those are our explosive, powerful strength type fibers. And so you can see the logical conclusion there of male advantages as far as strength and things like that. Males have larger hearts, pump more blood per beat. They're stronger. Even if we account for differences in body size, males' hearts are still larger than females. All right. Which I tell my students all the time that when they're, when they're on a date or something, for the guys to always say, hey, listen, honey, I love you, and I've got a bigger heart than you do. I'm not sure that's a winning thing to say on a date, but the students get a kick out of it. All right. Males have larger lungs, and the lungs are actually placed a little bit differently in the chest because of the Y chromosome effects. And those larger lungs support males being able to get more oxygen in the blood. After puberty, males have more red blood cells, more hemoglobin, are able to transport more transport more oxygen in the blood. So you can see these advantages, of course you can explain those to sports. And males have denser bones, higher bone mineral density. Males have a lot lower risk for osteoporosis than females. Males' long bones in the arms and the legs are longer than females, which is a big reason why males are taller than females. And so we can look at all of these traits, these morphological, physiological, anatomical traits, and see differences between males and females. And so if we look at this, all right, and so here we've got normal distribution curves. You've got the female curve and you've got the male curve showing, if we were to graph out all of women, if we were to choose height or bone mineral density or lean body mass or muscle size or something like that, we would have the female curve and we would have the male curve, right? And there's a difference in the normal distribution there. Great example is body height. The average adult female is 5'5" tall. Average adult male is 5 feet 10 inches tall. A woman who is in the 90th percentile for body height is like 5 feet 10 and a quarter inches. So women in the 90th percentile are only a tiny bit taller than average males. Typical woman, 170 pounds, typical male, 200 pounds, right? Which again are going to provide definite advantages in sports. Typical female, typical woman, about 24 to 30% body fat. Typical males, more about 15 to 20% body fat. So again, we can choose these morphological traits where there would be differences. And yes, there's variation. There are some tall women who may be taller than some men, but they're not taller than the tallest men. There are muscular women, and they may be more muscular than the average man, but they're not more muscular than the most muscular man. Same thing with heart size, same thing with bone mineral density. So we can do all these things, but there's still the normal male and female distribution in which there are differences between the sexes, which, I mean, honestly, that's why we do statistics, right? So we can take one population, another population, run it through our statistical test and see with a level of mathematical confidence if there are differences. One area I want to point out that there isn't overlap is testosterone. After puberty, all right, so before puberty, between about 6 months and the onset of puberty, there's not a difference in testosterone before males and females. But once males start puberty, typically around 11 or so years old, they get a huge increase in testosterone. And so if you look down there in the orange, we have the normal range for female testosterone up to about 1 nanomole per liter. The yellow is showing women who might have hyperandrogenism of some kind, causing increased testosterone concentration, but still going up to maybe 4.8 nanomoles per liter. And then you've got that big gap until you get to the male range of testosterone. So there's no overlap. So in an adult human being, if a man has functioning testes, even if they are internalized because of a disorder of sex development, they'll still have testosterone in the normal range. We know testosterone provides athletic advantages. That's why athletes want to dope, right? And that's why all the sports say you can't use anabolic steroids, because we know anabolic steroids, testosterone, it's going to increase lean body mass. It's going to increase muscle strength, about a 5 to 20% increase in muscle strength we would expect. Now you notice on there the line, that's the 10 nanomole IOC line, that's still in the normal range for males. And so I really have no idea how the International Olympic Committee or other organizations have said, oh, well, 10 nanomoles is the line in which a male can compete in female sports. It just doesn't make sense because they've got that huge gap between males and females. I do also want to mention if someone is undergoing what is called gender affirming hormone therapy, a male who's identifying as a woman, the goal is to suppress testosterone down to the women's level of about 1 nanomole per liter. So that 10 nanomole per liter is really just kind of an arbitrary number and it's not even relevant to those who are undergoing gender affirming hormone therapy. And so all of this, again, we can look at the factors that contribute to successful athletic performance. We can see male advantages there. And when I say male advantages, I'm not trying to be in any way belittling or diminishing of the amazing accomplishments of female athletes. I've got a lot of female athletes in my classes, and they're awesome, whether they're volleyball players or they're in track and field or they're basketball or they're swimmers or whatever sport. They're awesome. They're great, and they do amazing things, right? But we look at athletic performance, we can see these differences between males and females, and particularly after the onset of puberty. Now, as I go on a little bit, I'm going to talk about how there's differences before puberty, right? But we see huge differences after puberty. And so an example, I want to, again, acknowledge Dorian Coleman, who wrote an article about this for the Washington Post, an editorial, points out Katie Ledecky, amazing swimmer. I mean, Katie Ledecky's a 4-time Olympian. That's just amazing right there to go to the Olympics 4 consecutive times. You've got to be a great athlete to do that. She's got 9 Olympic gold medals, 14 total Olympic medals, 21-time world champion. She's got the world record for the women's 800-meter freestyle, right? And she actually has the 5 fastest women's 800-meter freestyle times. So in essence, she set the women's world record 5 times. She's an undeniably amazing athlete. Dedication, skill, training, nutrition, all it takes, along with coming from the deep end of the gene pool that determines athletic performance, right? But there's been 26 boys in the US that are 15 to 16 years old that have beaten her world record, right? The men's world record is 7% faster than Katie Ledecky's women's world record. In the most recent Paris Olympics, 26 males swam the 800-meter freestyle faster than the women's world record. And in the men's US Olympic team trials, 20 men swam faster than Katie Ledecky's world record, right? So she's an amazing athlete. She really is, but she's not even going to sniff the podium competing against males. Another example, and I think this is a great one, right? I kind of designed this with Boston in mind, right? Boston's a basketball city and everything. Nebraska is not a basketball state. Nebraska used to be a football state, but we're not much of a football state anymore. But hopefully that's coming back, all right? But you look from when the WNBA started in June 97 until May 24, there have been a total of 37 dunks in WNBA games. All right, so 27 years, 37 total dunks, and 26 of those dunks were by Brittany Griner. So only 8 WNBA players have ever dunked in a game. Contrast that with dunks in the NBA, where they're measured in thousands per season. Typical NBA game, you're going to have about 6.5 dunks per game. So in the NBA, they're going to have more dunks in a Saturday than the WNBA has had in 27 years. Now we can explain this. Typical WNBA player, she's going to be about 6 feet tall. Typical NBA player is going to be about 6'6" tall. The basketball for the WNBA is an inch smaller in diameter than it is for the NBA, but they're both playing on 10-foot hoops. So of course it's harder for a 6-foot tall person to dunk than it is for a 6'6" person to dunk. But again, this just exemplifies these sex-based differences and how they affect sports performance. Sorry, I need a little drink here for a minute. Anybody that saw my icons presentation, I am drinking caffeine-free Coke, not Pepsi, so I won't spill it. Sorry, no product endorsement there, just had to say it. So this is a great paper by Tommy Lundberg and Emma Hilton, where they took all sorts of different sports and looked at the female performance level, and that is set on this graph at 100%. I added color to this because their graph in the paper is black and white, so I thought the color would look nice. And then they set the male level above the 100%. And again, they looked at all sorts of sports, whether it's rowing or swimming or running or handball shots or pole vaulting. And you can see in these sports, the male advantage runs anywhere from 10% faster than women up to 30 to even 50% higher than women. Typical in weightlifting, males are going to be lifting 30 to 60% more than women, depending on what lift you're looking at. If we look at it for weightlifting, males in the lightweight category of weightlifting are lifting weights comparable to women in the heavyweight category. And you probably saw this in the Olympics with the controversy in the women's boxing. If you look at boxing power, punch power, on a pound for pound basis, males are punching with 162% more power. Keep in mind, 100% is twice as much, right? So they're punching 2.6 times harder, more power than the females. So when that Italian boxer, when she said that she had never been hit so hard in her life, that may very well be true. If she had never boxed against males going all out, she may not have been hit that hard. All right. And I want to point out that we can see these differences across levels. If you look at world championships, if you look at Olympic championships, if you look at college sports, if you look at high school sports, we see these sex-based differences across all the different levels of sports once puberty is set in. And you can even go down to your recreational 5K and see the differences. Look at the male time and the female times in the recreational 5K, or look at a local community weightlifting event, maybe put on a part of a community Olympics or something like that. And you see these sex-based differences in sports performance. And so taking that graph with morphological traits, doing a little changing of words, if we look at it in terms of athletic performance, again, we see this female distribution curve of normal performance for female athletes, and we see this distribution for male athletes. And so, yes, some women, some females are stronger than some males, but the strongest males are much stronger, 30 to 60% stronger than the strongest females. Yes, some women are faster than some males. Just go watch me at a local 5K and you'll see a lot of women faster. And I'm just a middle of the pack runner for men. And yes, it hurts my feelings when I see women running faster than me. My daughter-in-law, she had a baby in January, then ran a marathon in August. She's at least a minute per mile faster than me on any distance we try and run. And that's really hard on my feelings, especially considering she's got a young baby. But she's not faster than the guys her age that are training at the same level she is. Right. And so males are going to be 10 to 20% faster. And this is the important thing. We need to look at this when we're comparing similarly aged, trained, and talented athletes. Right. So we can't compare Olympic female athletes to males in high school, even though when we do, the males in high school still are probably doing better when you look at the best performances. And so this is from a paper that there was 26 of us around the world that wrote this paper, basically saying that the International Olympic Committee needs to do a better job protecting female sports. And so we can look at this, and there's a lot of stuff on this figure. And again, credit to Tommy Lundberg and Ross Tucker and Emma Hilton for conceiving this and putting it together. But if we look at the sport and we look at the difference between males and females, and then we look at the anatomical and physiologic factors that determine success in that sport, we can largely explain those differences based on biology, right? We can account for it. A lot of the difference is difference in lean body mass. but we also get into bone mineral density, bone length, heart size, lung size, cardiac output, all those types of things. And this stuff, it's well documented, right? All of this information I've been presenting on sex-based differences in sport performance. Honestly, this is stuff that you learn in undergraduate exercise physiology. You learn this in undergraduate fitness testing. You learn it in undergraduate anatomy and physiology. These sex-based differences in anatomy and physiology. Every exercise physiology textbook I've used from the time I was an undergraduate through my time teaching today points out these differences in the chapters on muscle or lungs or heart or those types of things. And a lot of the books even have a specific chapter on sex-based differences in males and females. And it's important to note, females have concerns when it comes to athletic performance that males don't, right? No male is going to have to worry about whether their menstrual cycle, whether they start having a period in the middle of a competitive event, right? And the effects of the menstrual cycle can influence carbohydrate loading and fat utilization and those things like that. It's not something any man's ever going to have to worry about. And if you look at the surveys on it, most female athletes are concerned that their performance will be inhibited or impaired somehow by where they are in their menstrual cycle. Again, that's not something males have to worry about. And again, there's just so many thousands of papers documenting all of this. So honestly, when you hear someone say that sex doesn't matter in sports, I really, really don't know what an anatomical and physiological based research they're looking at. I don't know which books they're looking at. All right, and so this brings up this idea that I mentioned too earlier. What about in children? Are there sex-based differences in athletic performance before children? It's important to note female athletes are not just simply smaller, less muscular males, right? It's not like the differences in males and females suddenly show up at puberty, right? It's not like suddenly 11 and a half years old, a switch is flipped and suddenly you've got a little boy and you didn't know if it was a boy or a girl before that, right? And so these female athletes are not simply small, less muscular males. They really deserve their own category and their own consideration. And the sex-based differences in athletic performance don't suddenly appear at the onset of puberty. Even though you'll see some papers stating that, you'll hear experts stating that, a lot of that is because we haven't looked a lot at athletic performance before puberty. Primarily, that's recreational. It's fundamental skill development. It's social. And so we don't have the records on that. You can't go down to your local elementary school and look on the wall and see who is the fastest 6-year-old on the mile run. But you can probably do that in your high school, and you might be able to do that in middle school because the sports become more important and more competitive at that point. So it is harder for us to have the information on children before puberty. But if we look at school-based fitness testing, which I'm pretty sure most of us have done, I'm pretty sure most of us didn't enjoy it in any way, shape, or form. You may have done the AFERD test. If you're my age, you may have done the presidential fitness test, or my middle school PE instructor had us do the Marine Corps physical fitness test. You may have done FitnessGram. If you're from Europe, you may have done the Eurofit. There's all sorts of different fitness tests that we do on children. And if you look at those fitness tests on children, they show that boys are outperforming girls on tests of muscular strength, muscular endurance, muscular speed, power. So things like how many push-ups in 30 seconds, or how many sit-ups in 30 seconds, or how long can they do the bent arm hang? How long does it take to run a mile, or these shuttle run tests? The boys are outperforming the girls. As young as 3 years old, you can see these differences, right? And again, if we look at the 90th percentile for boys versus the 90th percentile for girls, you see those differences. Girls outperform the boys on tests of flexibility. Generally the sit and reach, but it could be tests like that, right? And so this is just an example of putting up the percent differences between boys and girls in the 9 years old and 10 years old, which are pretty reasonable to say that those are pre-puberty. If anybody has hit puberty at this point, it would be the girls. Girls tend to hit puberty earlier than boys. And so if puberty provides an advantage, we should see that erased at the 10-year-olds, right? And we don't. You see at male advantages in standing broad jump, in hand grip strength, about 8 to 10%, sit-ups 8 to 10%, 11%, bent arm hang time. Look at that difference. 30% advantage for the males in bent arm hang time, reflecting the differences in musculature in the upper body between males and females even before puberty. And again, you can see the difference in shuttle run minutes and stages, which we might call the beep test, might be another thing, the pacer test, and then look at female advantage and flexibility. So while we may look at those and say, oh, those are gender stereotypes, but they're also biologically based determinations. And now people are going to look at that and say, well, that's physical fitness, not athletic performance. And that is true. We don't line athletes up at the starting line. Okay, everybody do push-ups, and whoever does the most push-ups gets the gold medal. We don't bring them into the lab and hook them up to the metabolic cart and measure VO2 max and say whoever has the highest VO2 max wins. But definitely enhanced physical fitness is better for performance, right? Otherwise, athletes wouldn't spend so much time on the weights and conditioning and things like that to try and improve performance. And so I wanted to look at some athletic performance. And so this is from 2023 Nebraska USA Track and Field Junior Olympics. And so I took the boys' times in the 8 and under age group, which is the youngest group for USA Track and Field, took the 9 and 10-year-old times and distances and such. And if you took the boys' times compared to the girls' times for the 8 and under group, none of the girls would have gotten a medal. And you just got to ask yourself, if the girls saw all the boys getting the medals in the 8 and under age group, are they going to come back at 9 years old? And so a huge advantage to having a male category and a female category is it gives the girls the opportunity to succeed, to get medals. It increases the number of medals that are being earned, which is going to help facilitate greater athletic engagement. You look at the 9 and 10-year-old age group, and yes, there's a few girls getting medals, but still most of the medals are going to the boys. Now, I know you're going to look at this and you can say, well, that's Nebraska, right? And when you think track and field, you don't think Nebraska. And the motto for tourism for Nebraska a few years ago was Nebraska, honestly, it's not for everyone, right? So let's go to Arizona, right? Think about Arizona. Much more conducive to year-round training in Arizona. So you'd think more of it as maybe more of a track and field state, but we still see the same thing. In the 8 and under age group, very few girls would get medals if they competed head-to-head with the boys. And so again, we see these male advantages. And if we take this to the National Track and Field Outdoor Championships, same type of thing. You got a few more really outstanding girls there who would get some medals that maybe they wouldn't have at other levels, or maybe they did at other levels, that's why they're at the national level. But you still see most of the medals would have gone to the boys. Now, I realize taking individual track meets in these events, this isn't a statistical scientific analysis. So I did a statistical scientific analysis. So some colleagues and I, we collected the data from USA Track and Field Youth Outdoor Championships and the Junior Olympic Championships. So there's 2 of those held each year, usually one more East Coast, one more West Coast. So you've got 2 different events of the year to get the best youth athletes together. They compete against each other. We looked at the running events. So the 100, 200, 400, 800, 1500 meter run. And on average, the boys were faster than the girls. And if you took the fastest boys, they were faster than the girls. And this is in the 8 and under age group. You see the same thing in the 9 and 10-year-old age group. If you want to see kind of how it looks at, we took all of the numbers. This is particularly from the 800, but you can see the pink circles for the girls, the 8 and under girls. You can see the blue circles for the 8 and under boys. You can see the pink squares for the 9 to 10-year-old girls. You can see the blue squares for the 9 to 10-year-old boys. And you can see pretty clearly the fastest boys were faster than the fastest girls. And you can see that stratification where, okay, yes, there's a very clear difference between how fast the boys are running and how fast the girls are running. In statistics, we'll calculate an effect size. And if you have a large effect size, it should be plain to the naked eye without needing any kind of statistics to see those differences. This would be a large effect size where you don't really need statistics to tell you there's a difference here. But we have statistics that say there's a difference. And so there's been a few publications looking at this. We've got Jack Senefield, Sandra Hunter, their student Mary Atkinson looked at this. David Handelsman has done some work with this. I've done some work with this. And so if we look at running, on average before puberty, boys are faster than girls, 3 to 7%, and the fastest boys are faster than the fastest girls. On average, you see the differences in swimming. Now, the differences are smaller in swimming, but they're still there. And throwing, you see huge differences. Jumping, maybe 7%. But if you look at the shot put and javelin, you might be up to 20 to 30% difference between boys and girls before puberty. Now, these differences in sports performance before puberty are smaller than after puberty, but they're still present. And again, that's one of the things we do as a scientist. We look, is there a pattern that's discernible? If you see the males consistently putting up faster times than the females, consistently throwing further than the females, consistently jumping faster than the females, all right, Bill Engvall, is that who it is? To say, here's your clue. Right? So there you've got a clue that maybe there's something going on. Why are there these differences before puberty? Well, mini puberty, the first 6 months of life, we're bathed in sex hormones. Boys have a much higher testosterone level for the 6 months of life. Girls have higher estrogen levels the first 6 months of life. They call that mini puberty. Is this a lingering effect of mini puberty that sets boys on a path where they're going to have more lean body mass? Or is it something to do with the Y chromosome? There's not been much research looking at this, so this is a fertile field of research for people to look into. But before puberty, males typically have about 10% more lean body mass than girls of the same age, right? And we know lean body mass provides sports advantages. There's slight differences in the pelvis shape, even at 8 years old. Boys are going to have a more narrow pelvis that's more conducive to higher running efficiency, better jumping performance, right? And before puberty, boys have a little bit larger heart and lungs and cardiovascular, cardiorespiratory advantages. Now, people are going to say, what about social factors? And it's undeniable. Boys engage in more rough and tumble play than girls. All right. I was a Cub Scout leader when my youngest son was in Tiger Cubs. So I've got 7-year-old scouts. Boy, you turn your back on them and they were piling on top of each other and wrestling with each other. And I have no idea why. Whereas my experience helping my wife out with girls or helping people with girls events, the girls didn't seem to do that, right? So yeah, there is some kind of social factor there. And again, Carol Hooven wrote this amazing book on testosterone, and she goes into these effects of testosterone on how it affects, mental thinking and psychology and, physical aggression and those types of things. Another thing we see is girls tend to be more drawn to swimming. By having more girls participate in swimming, it's a greater likelihood you're going to find the really great girl swimmers, which may be part of the reason why the difference between boys and girls is smaller. Also, it seems like, some anecdotal evidence indicates the girls seem to enjoy the training more. And so maybe they work on their stroke a little bit better. They have more social engagement from it. And part of this, why we have more girls in swimming, is because they don't have football to take them out of swimming. Right? Football is kind of this monster in the room when it comes to trying to come up with male-female equity in sporting opportunities. And we still haven't figured that one out in 50 years, but there's got to be a way to figure that out. But 2 great studies out of Denmark. And I think if we want to look at a country with gender equity, Denmark might be one we'd put up there and say where their social expectations for males and females are as close to equal as we're going to find. Well, these 6 to 11-year-old boys and girls, when the boys and girls engage in the same amount and intensity of physical activity, the boys still had a higher VO2 max. The boys had more lean body mass. The boys were fitter than the girls. And so what would that would indicate is if the girls want to be as fit as the boys, they have to train even more, which I think that'd be really insulting to a lot of our female athletes to say, well, just train more to equalize the difference between males and females. I know I look at my female student athletes and they're training a lot. If you train them anymore, you're probably going to get into counterproductive effects of overtraining. All right. So this, and I realize I'm going a little long here, but I still got to hit this stuff because it's important. What about gender affirming hormone therapy? Which by and large, we're talking adult males who identify as a woman, reducing their testosterone concentrations, or boys going on puberty blockers before puberty. All right. So I've drawn 2 kind of normal curves. All right. I just traced these over some previous normal curves that I had seen. So that's my drawing, trying to approximate the differences in lean body mass. So you've got females there in the pink, you've got males there in the blue. Typically, adult males are going to have about 45% more lean body mass than females. Right? And there's been 18 different studies that have looked at this, that have looked at what happens when a male reduces testosterone for a couple of months to a couple of years, right? Up to 2 or 3 years. And actually, I've just reviewed a paper recently that's going on for more like 5 to 6 years of testosterone suppression. And yes, reducing testosterone levels in a male does reduce lean body mass or muscle size or muscle mass, various measurements of those. And so that yellow line, that yellow dash line, is representing the reduction, anywhere from about 0 to 5% reduction in lean body mass, right? It's not going to erase the difference. So the more muscular males might have less muscle mass than they had, but they're still probably going to have more muscle mass than the more muscular females. And we can see that. We look at our studies on transgender individuals, transgender women, they have more lean body mass than comparably aged women, comparably aged females. If we look at this for muscle strength, you see the same type of thing. All right, so you see the female strength there in the pink, the male strength there in blue. We've got 8 different studies that have looked at muscle strength in males that suppress testosterone for gender-affirming hormone therapy. And strength is reduced anywhere from about 0 to maybe 9% reduction in muscle strength. And so the peaks on those lines are 45% difference, right? Males are typically 30 to 60% stronger than women. So I set the difference at those peaks at 45% difference. And that yellow line, again, represents the reduction. Very informative if you look at the hand grip strength, right? Hand grip strength of trans women, so males who identify as women that have suppressed their testosterone, typically sits around the 20th percentile when compared to other males, but it hits the 90th percentile when compared to women, right? So that really illustrates, one, the massive differences in strength, particularly upper body strength between males and females, and also illustrates how little testosterone suppression reduces the strength. When they're, okay, so they're in the 20th percentile compared to other men, but they're in the 90th percentile when compared to women. All right. If we look at running speed, we don't have a lot of information on running speed. We have 2 studies looking at trans women in the Air Force. All right. And so I've kind of compiled those 2 studies into this graph. One study only went for about 2 years. The other study went out to 4 years. At baseline, before any testosterone suppression, these trans women were running 18 to 22% faster than their female colleagues. And that pink line is showing the female performance. The blue line is the males, 18 to 22% faster in the 1.5 mile run. After a year of testosterone suppression, the trans women were 11 to 12% faster. After 2 years, they were 6 to 9% faster. After 3 years, the trans women were still 6% faster. After 4 years, there was not a difference between the trans women and the female athletes. But I've got a big, huge caveat here. And that's where you see that N equals, all right? So there was 223 trans women at baseline, and there was 15 after 4 years. And so that leaves us like 208 unanswered questions about why did there, what happened with those other 208 trans women for their running speed? Why did they not stick with this study? So I'm not going to hang my hat on this study and say that testosterone suppression eliminates female or eliminates male advantage in running. It reduces it, but I still wouldn't say it eliminates it because we just don't have the information there. All right. And so there's been 9 different review papers by 9 different groups of scholars looking at all of this research and concluding, yes, there are inherent male biologically based athletic advantages, and those advantages are not erased due to testosterone suppression up to, for these reviews, up to 2 to 3 years. Male advantages were not eliminated. And we've got a few other studies looking at it cross-sectionally, 8 years, 14 years, still showing inherent male advantages in lean body mass, in muscle strength, in VO2 max, things like that. And so now our just huge, gigantic question is, what about puberty blockers, right? What happens if we take a child before puberty and block their puberty, all right? So a few studies looking at body height, right? And again, we know males as adults have advantages in body height. So if you look at the body height in these trans girls, and then they start puberty blockers, and typically in these young children, they would go on puberty blockers for a few years and then start puberty blockers plus cross-sex hormones. When the children are just on puberty blockers, their growth is less than would be predicted. And so that white line is showing the predicted growth, the yellow line is showing the measured growth. And so puberty blockers seem to suppress growth while on puberty blockers, but once they start cross-sex hormones, so that would mean a male taking estrogen, growth accelerates, and then the growth reaches the predicted level. And so one of these papers is, the title of it is Trans Girls Grow Taller. And that's really it. There's no difference in adult body height between a male and a trans woman based on the predicted trans woman's height, right? So we know height is an advantage. Who was the basketball coach that said you can't coach height? We know height is an advantage in basketball. We know it's an advantage in volleyball. And this would indicate that puberty blockers, maybe while just on puberty blockers, it may suppress height advantages, but then when they go on their cross-sex hormones, the height advantages are erased. If we look at lean body mass, a number of studies have looked at lean body mass for a short period of time, only a few studies looking a little longer period of time. But if a male goes on puberty blockers, their lean body mass doesn't develop the way it would without the puberty blockers, but they still have more lean body mass than a typical female. And then so they go on the puberty blockers for a few years, and then they start the cross-sex hormones. And as an adult, they may have less lean body mass than typical males, but they still have more lean body mass than typical females. And again, we know lean body mass is a major driver of athletic performance. A lot of our sex-based differences in athletic performance can be described by the differences between males and females in lean body mass. Again, not the only one. We have the long bones, we have the heart, and all those things like that. But lean body mass is a major factor. And so putting all this together, I've got really 3 conclusions from all of this. One is that there's important biological differences between males, which typically we say mean boys and men's, and females, that means girls and women, and those differences are present before puberty. These sex-based differences give males, including males with disorders of sex development or trans girls or trans women, inherent athletic advantages over similarly aged, trained, and talented females in almost every sport. And those advantages are there before puberty. And then having a transgender identity with or without puberty blockers, testosterone suppression, cross-sex hormones doesn't erase those advantages. And I say that based on, there's about somewhere in the neighborhood of 40 different research papers looking at this, right? And they all show the same things, that male advantages in lean body mass, in body height, VO2 max, those types of things are retained even after several years of gender affirming hormone therapy. So once again, thank you everybody for joining in. I appreciate this time. I really, really appreciate WoLF giving me this opportunity to speak. And I'll let Sharon field questions to me.
Okay, so yes, to the first question, and Martinez, first of all, thank you, thank you, thank you. That was extremely comprehensive. That was exactly what we were looking for. You've answered a lot of things that, we've heard over the years, but really did not have the facts and figures to rebut. That was outstanding. I think you could tell you're getting a lot of kudos in the comments there. So the first question we got asked is this going to be made available as a recording? Yes, there is a recording in progress. We'll be putting it up on our YouTube channel. So feel free to share it with friends and family that weren't able to make it tonight. And if there are questions, please, I tell you what, Doc, why don't you turn your share screen off? And you can, end screen sharing so that you'll be able to see the audience. If you have questions, for Dr. Brown, please raise your hand and we'll be happy to call on you, or type them into the chat box, and we'll be happy to do that too. We'll share them with you. This is really, really, really good. I'm actually really tickled with how this came out and the way that you have really, you just really articulated some things that I was very interested in seeing.
Well,
all right, so Lisa H has a question for you. Go ahead, Lisa.
All right.
Unmute yourself and ask.
Hi there. Thanks so much. Well, as you can tell from my profile picture, I have some lived experience in MMA training, and just because of the gender disparity, or the numbers of people that find that an enjoyable sport. I've had to cross train with men, so everything that you've presented there has validated my lived experience, and also my concerns, about one of the things that stopped me from going anything past amateur was, the idea of being matched up against a transgender woman in the ring, because yes, men just hit harder and they hit faster. My question though is specific to transgender women. You made a lot of points about the lean muscle mass being, there being a specific advantage for them, and in terms of their height and their bone mass and all these things. Has anybody done any kind of studies on muscle memory? I'm acquainted with a number of transgender women who trained very hard in martial arts and trained very hard as children in hockey, and they are now competing in women's leagues. And I know muscle memory is such a huge thing. So even once you account for some of the changes that come about from hormone suppression and or cross-sex hormone therapy, do we know anything about muscle memory and how that may or may not impact?
So that's a great question. And I haven't seen any studies looking at the effects of testosterone suppression or cross-sex hormone administration on muscle memory. There's one paper that just very recently came out looking at reaction time, but it was a cross-sectional study, so it doesn't give you a lot of information on reaction time. But it seemed to indicate that there may be a little impairment of reaction time, which probably is because of the impairment of muscle strength, right? So the muscles may not move quite as fast, but it still didn't erase the differences between males and females in terms of speed of movement and those types of things. And it does get interesting because another thing that goes along with muscle memory comes down to the nuclei of the muscle cells, and training the muscle cells, you get nuclear proliferation within the muscle cells. And there doesn't seem to be a reason to think that that is going to be erased because of transgender, cross-sex hormone use. There's still a lot that we need to learn as far as maybe sports-specific application, and just for health applications, honestly. So someone who's undergoing this gender-affirming hormone therapy really knows what to expect. But I don't really see a good reason to think that it would be erased to enough that it would anyway wipe out the male-female difference.
Okay, are there additional questions for Dr. Brown? Go ahead and raise your hand or type them in the chat. Dr. Brown, people are curious about the backstory on the library, but we can do that in a second. Emily, go ahead.
Hi, can you hear me?
Yes.
Yes.
On one of the graphics towards the beginning, you showed that males tend to have more type 2 muscle fibers than women do. I've seen trans activists claim that the hormone treatments literally change the muscle fiber type. Is that possible? Does that happen? Or is it like once you have type 2, it stays type 2?
So that's a really, really great question. And there are still some questions in exercise science. Does fiber type change? But by and large, fiber type is determined by the neurons that innervate the fibers. So you have fast twitch nerve cells that activate fast twitch muscle cells, and you don't tend to see change in the neuron. So I don't see any reason why testosterone suppression would cause type 2 muscle fibers to change to type 1. Now, what may happen? We see what is called disuse-related atrophy. If you're not using your type 2 muscle fibers, they go away. And that's a problem for a lot of us as we age. I mean, when was the last time you saw somebody my age go sprinting unless they're trying to grab their grandchild who's grabbing the puppy or something, right? So by not training those type 2 fibers, the type 2 fibers might go away, but there's nothing out there on that. I have not seen a single study looking at muscle fiber type analysis in trans women. So for them to say that gender-affirming hormone therapy, testosterone suppression changes the fiber type, I don't know where they're coming up with that, because I just haven't seen anything looking at that. And it doesn't make sense. It really, really doesn't make sense, because fiber type tends to be determined by your genetics, and we know you can't change your genetics.
Okay, thank you. I kind of suspected, but it's nice to have it confirmed. Don't know where they pull this stuff out of.
Yeah, some of the stuff they just kind of seem to come up with a good hypothesis, but no evidence to support it. Good question.
Yeah,
Thanks.
that's how it goes arguing with these people, but it's good to have the facts so I can respond to it. So thank you.
Dr. Brown, question has come out of the chat, which is if a male were to drop their testosterone by suppression to female levels, first of all, is that even possible? Sonia's asking this question. Sonia, you've got your hand up. Do you want to finish asking it? Sonia, I'm opening it up if you want to ask the question that you put in the chat about dropping testosterone levels in a male. Wouldn't it be incredibly dangerous for that person? So Dr. Brown, I don't know if it's, I don't know if Sonia can unmute herself, but if let's say a male was able to, I don't even know if it's physically possible. Is the male able to suppress their testosterone to the level that it would be in a female? Is that possible?
And so, yes, if you look at the Endocrine Society standards, that is the goal, is suppress testosterone levels down to normal female levels, which is going to be about 1 nanomole per liter. You look at a lot of the research, and that's honestly what they do. The female's testosterone, or sorry, the trans women's testosterone level is to the level of a female. Now, it's interesting on this. I was in a conference a couple years ago, gender medicine, thing like that. There were two different presentations where the scientists were getting up and showing how this testosterone suppression, estrogen administration was increasing the risk of embolisms, thrombocytosis, things like that are, blood clots in the blood vessels, basically. But they insisted that it was life-saving treatment. And so I just kind of was just stunned at that to see they're saying, okay, here we're increasing this risk of serious health complications, but insisting that somehow it's life-saving. And so, yes, there is information that suppressing testosterone like that in a male, and I think it's more particularly the estrogen administration, but you're taking cells that are made to have testosterone and suddenly depriving them of testosterone, giving them estrogen. I just have a hard time believing that it is good for long-term health. And if you read a lot of the stuff of detransitioners, they'll talk about how their health has been so negatively affected. And there is, again, research showing increased risk for cardiovascular diseases and illnesses, those types of things.
Interesting. As a follow-on comment to that, Nancy posted a comment that males that identified as transgender argued to the IOC that it wasn't good for their mental health, that they needed a certain amount of testosterone, and so that that would be higher than what you would have females at. And
that makes sense. That makes sense. I mean, people will argue if there's brain sex differences, but here's the weird thing: testosterone doesn't cross the blood-brain barrier. Testosterone gets converted to estrogen, so it's actually estrogen that gives males a male brain. The testosterone gets converted to estrogen. But still, yeah, it would make sense that a male brain is designed to have male levels of testosterone.
And this may be a question that you might not be able to answer, but this has come through the chat as well, that, we've seen a lot of doctors and we've seen medical associations basically claim there's no inherent advantage, yet all the stats you showed us tonight is that a trans identifying male does have an advantage pretty much no matter what they do. And we're curious, and you might not know the answer to this because I know there's political forces and stuff in play here, but why are medical professionals and why are even medical associations not being open with this kind of information?
So that's a great question. And I'm just going to speculate a little bit here. And so again, I go back to 2015 when you have the NC2A and the IOC policy and nothing was coming out, right? I kept expecting something. One of the giants in the field of exercise science, some of these experts that have really studied female athletes for years to say, no, wait, this doesn't work. And they didn't say anything. And it just makes me wonder, were they just scared that if they said something, it would destroy their career, ruin their credibility? Who knows? I think we can see in Tewksbury, Massachusetts, right? Cancel culture is real, right? And so people are concerned about that. I also think that there are political forces at play. Unfortunately, we see a lot of political division in not just American society, but lots of society where you have one political side and another political side. And we may not be willing to disagree with our political party, even if we disagree with what they're saying. We're not going to say it publicly. I don't know how that has all affected the medical organizations. You can see speculation that maybe it comes down to money. I don't know on that. I'll just say that's speculation. But it does make me wonder. I do appreciate that the American College of Sports Medicine just this past year put out their consensus statement on sex-based differences in athletic performance, stating that sex is the primary biological determinant of differences in athletic performance. And within that consensus statement, they did review some of the literature I cited here and came to the same conclusions. Within that consensus statement, the American College of Sports Medicine was very careful to say that this is not a statement on transgender, and we'll have a more thorough paper coming out later. But they did make a lot of the same conclusions I have, especially on the sex-based differences.
Interesting. Okay. Yeah. And I do think there are political, obviously we know that there are some bigger forces in play. Like we're aware that Dr. Rachel Rick Levine, the health and, Deputy Health and Human Services Secretary for the United States, lobbied the WPATH, right, that sets the standards for transgender, for the things that he wanted to see included in WPATH's recommendation, even though we've seen from the release of some of the WPATH files that some doctors within WPATH worried about these very aggressive recommendations, but they didn't really feel like they could push back. And then the United States used those same recommendations to be able to push, the standards that they themselves had lobbied for, right? So it's almost like asking defense contractors, what should be in the defense bill?
Yeah.
Why don't you tell us how we should, what we should put in there, right? So,
Yeah, and the
so
cast review does a good job explaining that circular referencing, how one professional society cited another professional society, and then the second professional society cited the society that cited them. It's just, this circular logic.
it
So,
was extremely circular, right, to get the agenda that they wanted,
yeah,
to push forward, and supposedly backed by the science, backed by the professionals. So, yeah, we're familiar with some of the dynamics of how we got here. It just, after watching your presentation, it just does not make any sense to us why the IOC, the NCAA, and others just aren't doing the straightforward math that you've presented here, and saying, no, they are, the sexes are different. You can't turn a man into a female, and therefore we should not be putting them in women's sports. It just makes no sense to me that they've acted like that's not there.
yeah. Yeah, and that's where actually it's interesting with Thomas Bach stepping down from the IOC, and there's a push to hopefully Sebastian Coe will become elected president of the IOC because he has really worked with World Athletics to say, yeah, sex does matter, and we need to protect the female category. So we can keep our fingers crossed that Sebastian Coe becomes the president of the IOC.
And may sanity break out and reign.
Yeah.
That would be a wonderful thing. All right. Any additional questions from our audience? And boy, y'all have been very, very engaged this evening, and we really appreciate you spending the time with us, and really appreciate you, Dr. Brown, for spending the time with us to walk us through this. This is super helpful, very insightful, and really is exactly that reasoned discussion that we were looking for, of like, you just can't change these facts. These are those facts.
Yeah.
So
And,
really appreciate this.
And I really, really appreciate the opportunity. I really, really do. This is so awesome to be able to do this. And I see some good friends on here from being at icons and other things, and see people on here I don't know, but I'd love to get to know you. I did notice in the chat, somebody asked if I worry about my personal safety. A little bit, but not much. I'm in central Nebraska. It's a nice small town. And honestly, my neighbors all agree with me. So if something were to happen in the neighborhood, I've got a couple of neighborhoods that are really large individuals that would have no problems coming out to protect me. Um, I've worried a little bit about my profession, but I actually had a reassurance from one of the administrators of my university, said that they will respect my First Amendment rights. So that was really nice and reassuring.
I am glad to hear that. I am hoping that you have a successful presentation tomorrow night as well. I know some of our folks will be. I think Sonia for sure is going to get on with you tomorrow night, and I hope some of our other folks will as well. I'm sorry that you had such a kind of upheaval and kerfluffle this week with Tewksbury canceling, and then doing an about face. I'm so grateful that you were able to pivot to giving us this presentation tonight. It was really good, and I think it was well worth it to platform you. So I'm tickled you did this. Hope we might have you back again on some other panel discussions if you're willing, because this kind of information I think is really it was very, yes, it was long and it was detailed, but it was very clear, it was very concise, and it was very evident that we just cannot change people's sex, and we cannot make them into what they are not. And I am very grateful that, from the sports perspective, you really made that very clear. So, that was very helpful for us to see that data on the difference in performance, the difference in body structures, muscle mass, all of that. And especially, I appreciate that you went and looked at pre-puberty. And I appreciate that you looked at through development, that, this was very comprehensive. So thank you.
All right. Well, thank you, Sharon. And I'm happy to help out. If you need me, let me know, and I'll do what I can to help out. This is a really important topic. And to a certain extent, I don't have a dog in this fight, as far as I don't have a daughter that's a competitive athlete. I'm not a competitive female athlete myself. I don't have daughters or granddaughters that are doing that yet. But this is important for my female athletes that I have as students, and for my friends that have daughters in this area. And so and this is an important scientific topic. It
Truly
really is. And we can't sacrifice science on the basis of whatever. So
No, and I super appreciate this, because I know you can understand a lot of information is floating around out there. Some of it's really garbage, you know, and so, but it's really hard when you first start looking at this, like what's true, what isn't, I don't know, has something changed, you know, so you can understand people, you know, sort of wanting to give the benefit of the doubt. But then, you know, being like, yeah, but the reality just doesn't, it just doesn't seem to match up. So I really appreciate this because you've made this abundantly clear that there are significant performance differences, that they start, you know, very early on, and that, you know, there's not really an opportunity to erase those, you know, by medicalizing them. And so I appreciate that because that is what a lot of girl athletes have been saying, is that, you know, this is not fair. Right. And that they are definitely noticing a difference. And so you've been super helpful here. And I want to say a special shout out to Massachusetts for Women, MA for Women, who I believe contacted you for, you know, the original presentation at Tewksbury. So grateful that they found you and that we've then found you, you know, because this is exactly the kind of information I think a lot of us have been looking for. So much appreciation and thanks to you. And thank you to all of you for spending time with us tonight on this really important topic. We will get the video up. And Coach Blade, yeah, you've been a fierce advocate in this, and I so appreciate it. Really trying to draw awareness to this, and it's really, really important. I think it's important for school policy. It's important, as Coach Blade points out, you know, it's important in the medical profession, but it's important for girl athletes and to protect their rights, right? To be able to have, you know, the sports that were guaranteed to them via Title IX in this country, and other legislation in other countries. So, wow. So thank you. All right. Good night, everyone. Thank you for joining us. Please stay on our email list. Keep up with us. We do this kind of thing around here. And Dr. Brown, thank you so much for joining this evening. It was an awesome thing to host you. I really appreciate it.
Thank you, Sharon. Thank you very much. Have yourself a great night.
All right. Good night, everyone.